Now listen and look for this video. Please concentrate.
The essential understanding for this lesson is the volume of a solid figure composed of rectangular prisms can be found by adding the volumes of each rectangular prism. Previously, students used formulas to find the volume of rectangular prisms. They also found the area of composite two-dimensional figures by decomposing them into non-overlapping rectangles, whose areas they found and added. In this lesson, students find the volumes of composite three-dimensional figures by decomposing them into non-overlapping rectangular prisms and adding the volumes of these prisms. This problem is key because students are asked to find the volume of a three-dimensional figure that is the combination of two rectangular prisms. Listen and look for students who view the figure as the combination of an upper rectangular prism that is 4 centimeters long, 2 centimeters wide, and 5 centimeters high, and a lower rectangular prism that is 4 centimeters long, 4 centimeters wide, and 2 centimeters high.
Look here. This side equals 7. This one equals 5. Each two opposite sides are equal. Then this one equals 5. Okay, this is 5 and this is 7. What is the remainder here? 7 subtract 5 from 7, it will be 2. This side, small side, equal 2, and this 2, and this 2. If you can separate the figure into two prisms, you can find the volume of each one. The upper one, its dimensions 4, 2, and 5. So its volume equal 5 times 2 times 4. And the lower one, its dimensions 4, 2, and 4. So we can find its volume. Then we add the two volumes, okay?
After using a formula to find the volumes of the upper prism and the lower prism, they add their volumes to find that the volume of the whole figure is 72 cubic centimeters. These students did not find the volume of all parts of the figure. Draw lines to show students the prisms whose volume they found. Point out the part of the figure that they did not include in either prism. Have students make a sketch of the figure with its dimensions, and draw a line on it to separate it into two rectangular prisms that together make up the whole figure. One way to do this is to draw a vertical line that separates the tall prism from the short prism. Have students examine the tall prism to find that its height is 7 centimeters. Suggest that they cross out 5 centimeters as they do not need that dimension. For the short prism, they should be able to identify its width as 4 centimeters and cross out 6 centimeters. Finally, have these students calculate the volume of the tall prism and of the short prism using the correct values and add to find that the total volume of the figure is 88 cubic centimeters. Listen and look for other students who visualize a horizontal line drawn to divide the figure into two prisms. Then they apply a formula to find the volume of each prism and add to find the total volume. These students show an understanding of how to find the volume of a solid figure composed of rectangular prisms by adding the volumes of each prism. This understanding will help them as they solve problems involving the volume of composite shapes.
Okay, now we listen to another video for more understanding.
A building supervisor wants to find the volume of a storage building to determine how much storage space is available. How can you find the volume of the building? You can find the volume of the building by using the formula for a rectangular prism. First, separate the building into two rectangular prisms. Then, find the volume of each rectangular prism and add the two volumes together. What is the formula for finding the volume of a rectangular prism?
Select your answer.
The formula for finding the volume of a rectangular prism is volume equals length times width times height. Find the measurements for length, width, and height of each prism to set up your equations.
Okay, the prism number B, its dimensions 10, 9, and 7. Okay, look here, 7, 7, 7. The total here is 12, and the small one is 7, so the remainder equals 5, 5, and 5. So the dimensions for the upper one or for A, 5, 4, and 9.
The length of prism A is 4 meters. The width is 9 meters, and the height is 5 meters. Let's figure out its volume. Volume equals length times width times height. 4 times 9 times 5 equals 180. The volume of prism A is 180 cubic meters. The length of prism B is 10 meters. The width is 9 meters, and the height is 7 meters. Let's figure out its volume. 10 times 9 times 7 equals 630. The volume of prism B is 630 cubic meters. Add to find the total volume of the storage building. 180 cubic meters plus 630 cubic meters equals 810 cubic meters. The building has 810 cubic meters of storage space.
Okay, now we move to the practical part. Hi guys, now the practical part. Okay, how to find the volume of a composite or compound figure like this. Okay, determine before you solve this problem which two cubes or two prisms you will choose. Okay, now we can choose this one on the right and on the left, or on the upper and on the lower one. Okay, look to the upper one. We divided the two prisms into upper and lower. So now, how to determine the dimension of each one? Look to the upper one, length, width, and the height. This is height. Okay, this is 8, the height of the big one. Okay, we don't need this 8, we need this one. Look for the equal height for this one. Look here, this equals 6. So it's 6 and this is 6, so the height equals 6. Or this one equals 8. Okay, this one equals 2, so equals 2. Now 8 and 8, and this part equal to the remainder equals 6. So you can find the height by two methods. Okay, here he gives me 6, the height, and base and length. This is the upper one. The lower one 7 and equals 10 or 15. Yes, 10 for the left one, but we need all the lower one here. So the base equals 15 and length 7 and height equals 2. Now we determine the dimension of each one, so we write the volume. The volume of first figure 5 times 7 times 6 equal 6 times 5 30, 30 times 7 0, and 210 cubic inch. The volume for second one equal 7 times 15 times 2 equal 210. Add the two volume, so the volume equal 024 420 cubic inch. Okay, look to the next one. The upper and the lower. The upper, the dimensions 5, and this one equals what? Equals this side, equals this side, equals this side, so equals 8. And the height equals 5. So the first cube or the first prism, its dimensions 8, 5, and 5. This is the upper one. The lower one here 8, 7, and the height equals 2. So we have 2, 7, and 8, and for the upper one 5, 8, and 5. So the volume of the first one 5 times 8 times 5, it will be 200 centimeter cube. And the volume for the second one 2 times 7 times 8 equal 2 times 7 14, 14 by 8 equal 112. So we add the two volumes, volume equal 312 centimeter cube. Okay, look here, we have upper and lower, or right and left. Here we use upper and lower. Now here we use right and left. Okay, the right one, its dimensions here 6, 2, and its height 9. 6, 2, and 9. And the right and the left one here this one. Okay, 8 and 5 and 6. 10, the total one. We don't need 10. We need 8, 5, and 6. Here 6, 8, and 5. So the dimension 6, 8, and 5. So the volume of first one equal 6 times 2 times 9 equal 108 cubic feet. And the volume number 2 equal dimensions 6 times 8 times 5 equal 240 cubic feet. So the volume equal, we add 8, 4, and 3, 348 cubic feet. Look at your homework here. Okay, this question we can, this is the same for solving one. Okay, we can divide the figure upper and down. Upper 3, 2, and its height 4, not 7 for the total, but here we talk about the upper one. The lower one, its dimensions 8, 3, and 3. Then we can find the volume. The second one here, the upper one 3, 8, and its height 1, and the lower one equals 4 for the total, but I look for the upper one, the lower one 3. So 3, 8, and 7, then we can find its volume. Thank you.